Energy stored in a capacitor. Energy of a capacitor, which is always equal to the work done in charging the capacitor. So if we charge the capacitor to a small instant dq, then the work done can be written as dw is equal to v into dq. Here we can substitute the value of b, that is dw is equal to q by c into dq. Here to calculate the total work done, we can integrate. So dw is equal to integral q into dq by c. The initial charge of the capacitor is 0 and the maximum charge of the capacitor, which is taken as q. Then if we integrate dw, we will get the value w, which is equal to 1 by c into integral q dq can be written as q raised to 1 plus 1 by 1 plus 1 within the limit 0 to q. So 1 by c q square by 2 within the limit 0 to q. When we apply the limit, we will get the answer work done, which is equal to q 1 by c q square by 2 minus 0. So that this work done is only considered as the energy stored in a capacitor. That is, energy is equal to q square by 2c. And from this we can write, if q is equal to c into v, we can write the equation as energy is equal to c square v square by 2c. Here c and c cancel. We get the energy as half cv square. And the second equation, we can just consider energy is equal to q into q by 2 into c. We know that q by c is equal to v. So we will get the relation qv by 2. So to calculate the energy stored in a capacitor, we have to use three relations. One is q square by 2c and another one is half cv square, and the next equation is qv by 2.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.